Thank you for joining in. Thank you for your time today. Good morning, good afternoon, good evening, depending on where you are. I can see that we've got people from literally all over the world on this call, and it's great to have you here. Today, we're having a conversation about AI, which is, of course, one of those set of initials that is awful when you've got an Australian accent. Most people don't understand what you say, but I hope you get it, artificial intelligence. And I'm absolutely delighted to say that we're speaking with Alex Brooker from Cirium. And it'll be a one-on-one conversation where we, I hope, get through as many of the issues as we possibly can. So having said that, let me also say, this is the second in a series of monthly webinars that has been organised in conjunction with the European Aviation Conference Institute and GARS, the German Aeronautical Research Society. That is a group of people who collectively, I think, cover a really broad gambit of issues in aviation, from economics to policy and to regulation, and I think to legal issues as well, of course. And I think it's a really useful forum for us to have these sorts of conversations. So today, as I said, we're talking about AI, and we're delighted to have Alex with us. Let me start, Alex, perhaps by just very quickly asking you, how long have you been engaged in AI? Or let me rephrase that. How long has AI been a thing?
Well, thank you, Andrew. Let's start with starting with an easy question. It's great to be here. Thanks for the opportunity to talk to you. Good morning, good afternoon to all our viewers. So how long has AI been a thing? Well, a very long time. Artificial intelligence has been worked on for many years, decades, in fact, and has sort of ebbed and flowed in terms of popularity. There's quite an interesting period in the 80s and 90s called the AI winter, where it sort of, as a subject matter, fell out of favour, certainly in the UK, but obviously much more recently has come to the fore and has got a lot of people very excited, particularly with the most recent advances with generative AI, which is a topic I'm very interested in.
Now, I'm going to interrupt you on two grounds. One is, of course, the AI of which we speak today, which you've just called generative AI. Is that different to automation and autonomous operations and things like that?
It is. It's generative AI is I would say a significant step forward. It's a change. Something that was triggered. I think it got to a lot of people excited when Google shared the design for the transformer. But generative AI as an area of innovation and development is certainly different from my perspective. I think it feels very different to a lot of the other changes in technology through my career. I think it's as significant a change and a step forward as the dawn of the internet. Actually, it's very different to some of the other micro steps that we've had in the last 5 or 10 years.
That's a really major, that is a quantum change, isn't it? If it is as important as the invention of the internet, or the, whatever the word is, the development of the internet. Why do you say that? Why do you think it's that important?
I think it's the step change in capability that these new, in particular, large language models, but there are other kinds of generative AI as well.
Large language models, they're models where people talk very loudly. Is that what a large language model is?
Well, large language models, it's a particular subset of generative AI that focuses on natural language processing, the understanding of language, understanding how to predict the next word in a sentence to such an extent that paragraphs and reams of text or any kind of language can be generated or at inference time based on a set of training data using these neural network and transformer design.
You keep doing it. Neural networks and transformers. I guess what I should have done, it's my mistake, and I apologize. What I should have done is ask you as question number one, what is AI? Please give us a definition.
Well,
as
if
of
we
today.
start with a sort of the simplest definition, I think it's a computer system it's capable of performing tasks that historically have required human intelligence. So whether that's recognizing speech or making decisions or creating prose or writing a Shakespearean sonnet, it's something that traditionally you needed a human to actually perform that task. So a significant difference from, say, traditional systems and software development.
So what about that step we always have to go through when we log on to something and tick the box that says, I'm not a robot? Is that something that the robots can do? How do they answer that?
Well, that is an interesting use case. I think even with the latest changes, particularly in the creation of large action models, which is those of us who sort of keep our finger on the pulse will have seen discussions around the creation of these large action models that can perform tasks for you on the internet, such as clicking buttons and interacting with complex websites. So clicking a button or selecting which pictures on a grid are of bicycles or traffic lights. Those kinds of tasks traditionally, they were created as these barriers. I'm sure many of us on the call and watching this video will have experienced those kind of checks when they're using the internet and in normal day-to-day life. And it's those kinds of things.
I struggle to believe anybody on this call hasn't experienced those things.
Exactly. And some of them are genuinely pretty hard to do and quite challenging.
Alex, look, you don't have to make those sorts of confessions here. You're amongst friends.
But it's those kinds of things and those kinds of tasks that generative AI or an assistant alongside a human could undertake on behalf of a person, on behalf of a human, assisting somebody and acting on your behalf as a user.
Okay, so let's bring this back, or let's bring this to aviation. At one level, aviation must be the ultimate analog industry, mustn't it? I mean, unless we can invent teleporting, we're going to have to take a physical object from a place to another place. And that's going to happen in real time, and it's going to happen with real processes. I'm struggling. How does one digitize? How does one digitalize that process? For aviation, what is the interface between AI and aviation, the ultimate analog industry?
Well, I think there are certain things you're right to call out that won't change with aviation. So moving people and things from one place to another. And an aircraft, commercial aircraft, is a valuable piece of equipment. And so optimizing ourselves, optimizing around the use of that precious asset, that precious resource, is where the AI can help. There are certain things that won't change with aviation, but what can change is the process and optimization around that. So the data around that, managing how we value the asset, how we plan where to use it, where should we use it, where are the best commercial opportunities to use that asset, where should we launch a new service, and then obviously from a air traffic control, air traffic management perspective, how do we safely manage that network of these things moving around. So I think there's huge opportunity in aviation for AI across a wide gamut of use cases. actually.
Without asking you to give away any confidences, of course, do you have clients now that have got active AI systems, if that's the right word, active AI networks, working in their airline?
Well, I think what we do,
And
but I
if
think,
so, what is it that they're doing for those
well,
airlines, for your clients?
it's really interesting. I think if we just put the safety critical use cases to the side, I think it's really interesting to talk about some of the use cases that are away from safety critical things and are more in the realm of the sort of lower stakes use cases. So it could be estimated time of arrival prediction. It could be something around monitoring aircraft and their positions on the ground in order to detect what we've called ground events. So understanding when has an aircraft gone in for a particular maintenance check. And then if you can monitor that globally and understand across the global fleet which aircraft have gone in for maintenance at certain points, you can then construct a model around that and infer when and predict when the next maintenance check is and understand the potential forecast utilization for that aircraft asset. So that's very much a use case that's around observing aviation and observing the market rather than inside aviation and the operation of the aircraft themselves, whether it's pilots or controllers or those kind of use cases. So I think there's lots of very interesting use cases that are around observing aviation, and that's where sort of Cirium has been sort of traditionally focused. But there's lots of other work within airports around image analysis and understanding turnaround times and the various milestones associated with that. So there's a whole range of use cases, and I think there's a lot of really fun, interesting, and effective use cases that can be explored that actually stay away from the safety critical side of aviation.
Mm. At first, thank you. At first, I thought you were going to tell me that you've got clients who use it to, and I don't. This is going to sound much more derogatory than I mean it to, so I apologise. But you've got clients that are using it to speed up their accounting, if you like, to make fewer errors in those sorts of what we'd call classical back office procedures. Does that happen as well?
I think, well, most recently, some of the really interesting areas are around increasing the productivity of knowledge workers. So whether it's using traditional office-based tools, I think both Google and Microsoft have published reports. I think Microsoft just published their Future of Work report, which showed some really interesting data on the use of co-pilots just with the standard Office tool set of around sort of 30% productivity gains there. I mean, the proof will be in the pudding in terms of the rollout, but I don't think it's derogatory. I think there's a range of use cases that include running those kinds of projects, whether it's doing accounts or whether it's doing a sort of complex analysis of the tracked utilization of an aircraft over time and then creating that prediction. But instead of taking days or weeks to do a project to create a report, these tools can enable sort of much quicker execution of that project and achieve the same output with much less effort with the use of these sort of assistive tools.
You say much less effort. If you were the system, you might think it was pretty hard work. I mean, just, the fact that there's no effort for you doesn't mean that work isn't going on. But so if you like then, and again, to reduce it at some levels, step one, as you said, so far you in effect, you've talked about the safety critical stuff, which we don't want to talk about yet, but trust me, I do, and we will. The safety critical stuff, which sort of kind of involves highly trained humans in complex environments. And then on the other hand, you're talking about effectively speeding up day-to-day administrative processes and administrative is the wrong word, but day-to-day calculations and day-to-day analysis and things like that. It's just it makes our analysts better at analysing. Is that a fair summary?
I think that's a fair summary. So that what I was talking about, it is really the business of aviation, rather than the operation or operations themselves. And I think, there's huge opportunity there. But what I would also add to that is some of the most interesting use cases are around software development and systems development. In particular for aviation, I think I've been working. I spent my whole career in and around aviation. Not all civilian, but defence has similar challenges too. But for something like the development of software and systems and their accreditation, sort of the whole validation and verification process, confirming that a system does what we think it should do in a very formal way, and certifying that, I think there's a huge opportunity for the use of generative AI, right from the sort of the software development side all the way through the sort of requirements analysis, functional failure analysis, across the whole sort of tool chain, end to end, that can actually make a big difference to productivity and dare I say it, get the cost down by improving the tools so much. In particular, it was only the last 2 weeks, just alone in the last 2 weeks, there have been big releases by a lot of the providers. But if I mention one, the Gemini 1.5 model from Google.
I think I had a Gemini 1.5 in 1974. I've got about 25 miles to the gallon. Yeah.
And I think the model that's not actually available to the public.
I beg your pardon, I interrupted there. Gemini 1.5 made by Google,
Gemini,
did I hear you say?
Yeah, that's right. The Gemini 1.5 model made by Google that has, I'll use a term now, a context window of up to 10 million tokens, but I will explain what that means.
You're going to have to.
Yeah, so with something like a ChatGPT or some of the other tools that you may be familiar with, have used on the internet, where you can there's a little counter in the bottom right where you can only have sort of 20 back and forth conversations within one chat. You may have noticed that there's a limit to how much the conversation can go before you have to start again and start from a clean slate. That's because those models have a limited context window of how much text they can have in each call to the model. The reason I mentioned Gemini 1.5 is that this new model has potentially up to 10 million tokens. So a token is a portion of a word. So if I were to say it's just millions of words in a single query, then you could potentially use that model you could provide the model with a whole code base, the requirements, the product definition document, the system design, it just in a single request, and ask questions of all of that context and get very accurate answers back. And the reason I mention that as a particular example is that that's a very hard thing to do. And it takes a lot of time for humans to understand a full code base, plus all the documentation, plus the requirements. And just that example, I think, is something that being able to ask questions of that corpus in one go and get accurate answers back is extremely powerful, and actually unlocks kind of new use cases that just weren't possible even a month ago.
a number of issues to unpack in that, but just it sounds like that sort of process and thinking about it in the framework of airlines and airports gets you very close to the safety critical stuff, doesn't it? I mean, why would we do this if we weren't making the airport/airline more efficient, more effective, operating better, and so forth?
Why would we not do it unless, yeah. I think this, in terms of the safety critical side, I think that is, well, let's talk about how we decide that. We have a risk-based approach in aviation right now.
Well, indeed,
So
what made me think it was it sounded like what you were describing was effectively the process for getting certification, whether of a component or of an entire aeroplane, right?
Yeah.
Or a process. And if what we're doing is effectively using this to get certification, that is rubbing awfully close to safety critical, isn't it?
I think, yes, I think so. From that perspective, just for that use case area of talking about the V&V process, so the standard way for, if we just took ground-based systems, ED 109 and DO 278 or 178. I always get confused between airborne and ground, but there's those standards that we use and follow for building this stuff. It's very interesting with things like the EU AI Act and the executive order from the Biden administration, where what they're talking about for the use of AI and deployment in products is very similar to the risk-based approach that we use in aviation, where we create a risk matrix. We look at the likelihood, we look at the impact, we do a functional failure analysis and investigate and interrogate all the possible failure modes. And we collect evidence at every stage of development, and then present that evidence as part of an acceptance process to prove that the thing does what it was designed to do, and does it tick every requirement that was in the specification. And I think it's interesting that in the sort of the AI legislation and regulation that's coming down the track, there's a lot of similarity there, where we, system software developers, industry, but also academia, we're being asked to collect evidence as we go and show our working as we construct these systems, so that we can demonstrate that they do what we said they were going to do, or that what we want them to do.
Which brings me to my other question in all of this. You've described a process that could either lead to certification or could certainly lead to the development of standards, things like that. What's our level of confidence in this? How good, how right are the systems at the moment? How much confidence should we place in what's going on at the stage we're at now, before we get to safety critical?
Do you mean the generative AI systems?
Yeah, well, no, well, I guess I mean I mean the output of an AI system. You put in, either you've got a limited window for input, or you've got a nearly infinite number, but you use this system to drive a new standard for something. So let's not get it to certification, simply a standard process, something like that would normally be done by EUROCAE, by RTCA or whatever. And my question, I guess, is, have we done anything to say, yeah, no, that's really good, that's accurate, that's correct, that's right, or do we just take it on trust?
I think there are lots of issues right now. The models do hallucinate. They're very much like an excited.
Very hard not to get worried about that.
They're sort of, in many ways, they act like a sort of an excited Labrador puppy that wants to. You throw the stick.
That's okay then. Well, that's reassuring.
You say, I would like an answer. I've asked you a question, and they will do their best to give you an answer. They've been trained on data from the internet, lots and lots of emails and different sources.
What could possibly go wrong?
Exactly. And so
Yeah.
what's the part of, the features of those kind of training data sets are that very often we humans provide an answer, and it's actually quite rare to say, I don't know. Whereas I think with these models, they need to, if they don't know, they do need to say they don't know. I think that's very important. And in particular with trust, I think any well, I would say any person, but in particular within aviation, if you're working with a standard document or a table of data or a timetable or a schedule, and you see one number in a table or in an article, and you think, oh, that doesn't look right. I'm not sure about that. What's the assumption behind that piece of data? And I think these models have to earn the trust of the humans, of the users. They have to be able to show they're working. And so with any of the output that's generated, I firmly believe that we as users will have to be able to actually unpick what's the assumption behind that number in that table I can see. Can I drill down? Where's the evidence? Where are the citations to the various standards or data sources or data provenance? So that you can go and investigate. I think they have to, if I were to say it in a sort of soundbite way, they have to show they're working and be sort of verifiable.
But do you see a day when we develop an AI system that's effectively the AI police that go through other pieces of AI generated work and try to second guess it or try to work out what it's going to do? And then a very good question that's coming on the chat you may have seen. What sort of framework should we have for monitoring, for policing, for controlling this kind of stuff? And this is, I mean, we're still in the non-safety critical area, I hasten
We
to
are,
add.
yes, yeah, we're still non-safety critical. I think, so in terms of that, validating and evaluating, there are some really interesting areas around the use of what are called agents, AI agents, and that sort of uses a particular feature of the large language models where if you tell it to act like a aviation expert, then it might say things slightly differently when compared to if you ask it a question and say, please communicate with me as if you were writing a Shakespearean sonnet. In terms of what's happening behind the scenes, it's actually using different parts of its training data and tone of voice in how it communicates back with you as a user. So the use of AI agents...
I only hope the information gets put in correctly and it doesn't tell you to behave like a pilot, because then we'll have, pompous, condescending language everywhere we go. I'm really looking forward to that bit. I'm also trying desperately to work out what an aviation expert would sound like were one to be captured and distilled into a jar. But anyway.
Well, I think there's that. So just iterating on that point just for a moment more, you can ask an AI agent to act like a verifier and to review and inspect information that's flowing through the system and flag up any errors or inconsistencies in terms of the language itself that's being written. So you can add a reviewer agent into a system, but that leads to a slight side point where these are systems. The large language model is one component in a much wider system. So to the question around a framework, within this system, the LLM is just one small component where we will have other components such as the vector databases. We would have all of the global aviation reference data, the ICAO codes, the IATA codes, who are the operating airlines, the airports. There's a whole sort of gamut of reference information that's separate but is still part of that wider system. And so the LLM is just one piece, and its output has to be verified as as part of that system process.
But you speak here in the future tense. So we're still at a place where we've got AI systems being increasingly, I think it's fair to say, increasingly used to generate some of this stuff, which then we ask a human to validate. We may bring an agent in at some later point and tell it to think like an airline person, whatever the hell that might mean, and that's a scary thought, and get someone with a, quote, aviation mindset or an aviation brain to what's the word I want, to second guess it, to validate it, to reread it, a second pair of eyes. We're still at trust, aren't we? We're still back to trust. Is it just a matter of practice till eventually we think we can rely on this stuff?
Well, I think they have to, these systems have to earn our trust through trustworthy behavior. So they have to deliver results that are accurate, but
like your
verifiable.
Labrador puppy, like your Labrador puppy.
Well, like the Labrador puppy, but I think that they have to be integrated as part of the system with the ability to go back and check that data is accurate. So if there's a table of data in a generated report, we have to be able to go back in and verify that table is accurate. Where did it come from? What are the assumptions behind that? So I think it's a multi-stage process. I think what doesn't work right now is the simple sort of question and answer, and expecting that. We call it zero shot, but a straight question with a straight answer that comes back from something like a ChatGPT that has got good general aviation knowledge. But as soon as you scratch the surface and ask a follow-up question and then a second follow-up, you realize that its knowledge drops off very quickly, but it will try and answer.
They are actually pilots. They are actually pilots, right? Oh, if were I to be dystopian, you've almost painted a picture where we get the machine to do the fancy stuff, and then the human's job, their job is to go back and just check that every box has been ticked and that the numbers add up and that they're using the right sort of core. I mean, if you go back to the creation of computers, we thought that the computers were very stupid and they'd do this sort of drudge work and we'd do the thinking. Now it almost sounds as if, again, were I to be dystopian, it almost sounds like we're now at the reverse, where we do the drudge work and the computer does the thinking.
Well, I think there's a lot of drudge work in cleaning up data, tagging and managing unstructured data. There's a huge amount of effort spent by humans, and not least within Cirium. We have large teams of people who look after and manage our fleet database, and our future schedule, and many of our other data products. And they use the latest, say, traditional tools, and we're exploring the use of generative AI for those kinds of use cases as well. But a lot of that drudge work that can then free up those knowledge workers to focus on the more creative aspects. But there are still some challenges. In particular, one area that the current large language models fall down on, and this isn't to say that this won't change in the next few months, given the pace of change, but right now they don't have an understanding of the real world and its constraints. So, for example, the LLMs do not understand. GPT-4 does not understand that only one aircraft can occupy a gate at a time. Something obvious to anyone in aviation, and actually anybody who has an understanding of the physical world.
Not the passengers, but yeah.
But what that means is that if you ask generative AI or ChatGPT to design a sort of an arrival and departure sequence, how do you optimize the use of gates? Then, because it doesn't have that real world understanding, it then will make mistakes. And so what these models are very, very good at is text summarization and text generation, but they have to be given the accurate data. And you have to sort of constantly be aware that, okay, they don't understand those real world constraints. So this airline owns that slot. So a suggestion to simply change something around just doesn't make sense in the real world.
And this probably segues, doesn't it? Thank you. This segues, I think, into the safety critical stuff. I mean, I can hear controllers, I can hear pilots already saying, yeah, what Alex said, just exactly what Alex said, that, AI doesn't have an understanding of the real world, and the decisions we make, the safety critical decisions we make, they depend on a human understanding of the real world. Are you confident? No, sorry, let me put that differently. Are we going to get to a place where that isn't the argument anymore, or that argument isn't sustainable?
Will we get to a place?
Was that question a little
in
bit
a
too
few years?
convoluted? I'm sorry.
I'm suddenly staring out my window here. Will we get to eventually? Yes, I think we will get there eventually. But in particular for safety critical use cases, I think there are areas where you can do prediction, timing predictions, flow predictions that assist the human in that way. So there's still a human, even if they're not in every loop, there's a human on the loop reviewing decisions or suggestions that are made. But there have been lots of advances if we step out of aviation slightly towards self-driving. But even there, I think lots of people's real-world experience of some of these tools is there's a level of reliability that's still a challenge with those systems. And so with aviation, I firmly believe that these tools and techniques, amazing as they are, they have to prove themselves and earn our trust in terms of showing they're working and understanding how did they arrive at that result or that prediction.
So, yeah, absolutely. First of all, self-driving, I mean, it'll be irrelevant to aviation until you've got self-driving buses, because that'll be much closer to aircraft. But whoops, did I say that bit out loud? But before we get to pilotless aeroplanes or controllerless air traffic control, do you see intermediate stages that we're going to go through as part of this trust building, if nothing else?
Intermediate stages, yes. I think that the sort of rollout of new tools and new standards in aviation is evolutionary. It's not been revolutionary, particularly in terms of safety critical things, and not least because of all of the people involved and the training requirements. And this is a running global infrastructure. So you and I have both observed and talked about some of the challenges across the global air navigation plan rollout the last few years. And so all of those step changes, and there's some really, really good work going on. The CATS, the vision for 2045 is really exciting. Talking about digital transformation and the capabilities and actions there. There's been some really, really interesting work that's been done there that continues. So I think there will be an intermediate stage. I think there'll be much more assistive. So supporting decision support context that's provided, and it may be that these machine learning algorithms. Maybe it's not generative AI, but then there are lots of other subfields of AI. I mean, if we just took a much more accurate predicted ETA for aircraft entering a flight information region, that has its incremental value, but that has some value, and that those kind of tools, while not ChatGPT or a large language model, there are lots of areas in machine learning that are much more deterministic and controllable and understandable in terms of their outputs.
But I mean, frankly, at some levels, we've got all of that. It's just that we choose not to use them. The aircraft can tell you now when it's going to arrive at a particular point in space. It's just that the controllers refuse to use them, or we have systems built up, very conservative systems built up, that don't allow for that sort of exchange. Now, Alex, you and I first met in a discussion some years ago now about SWIM, which for those of us on this call of sufficient advanced age will know stands for System-Wide Information Management. And at the time, we thought information management was the new flash thing, and that somehow we'd get all this data and we'd use it. But we've been, as an industry, rubbish, haven't we, at exchanging data and making the data available and all of those things? Is that a fair observation?
I wouldn't use that word to describe.
Not rubbish, you'd rather trash, garbage.
No, I think
litter.
There have been some major challenges there in terms of the adoption of SWIM, and I was fortunate enough to be asked by CANSO to write the white paper on SWIM about 18 months ago, which looked at this issue. And I talked to a large number of ANSPs and talked to them about the pros and the cons and what had really happened. And it was fascinating because something that emerged was where the incentives don't line up across the aviation sort of stakeholder group, it can be very, very hard. So if you're writing a business case to implement a SWIM project, is the person paying for the project going to realize the benefits? Who gets the ROI?
It's my long-standing belief. The problem with all these sort of collaborative decision-making things is the person who pays the money doesn't get the benefit. Is there an AI system we could design that would get around that problem, do you think?
Well, that's okay. That's a really great question. I think there's a...
I'm sorry, it was meant facetiously, but that's okay.
Is there an AI system? I think it's because it's a horizontal technology that can be applied to many, many use cases. Then I think the software developer working on the next generation of an avionics package who has a more advanced testing tool set through the use of AI when they're literally writing the code and doing the software systems development, they see there's a benefit there. And I think, just as we were talking about at the start of the discussion around the business of aviation, the use case is looking at more of the financial side or the network planning or optimization side. So I think because generative AI and AI more broadly can be applied, it's a horizontal technology that can upgrade many areas. So I don't think there's one system, but yeah, I think it will eventually touch all of the stakeholders. But it's different to SWIM. I think there are some challenges there. I mean, one example where I was involved in one of the first cross-border arrival management project with NATS in the UK, and it was a long time ago now, 2015, 2016.
Yesterday.
But some of the discussions with airlines, airports, ANSPs, I learned so much in that project about those different incentives. If you have a ground delay program, the airline participating with the ground delay program is likely to receive a ground delay.
Yes.
Right. Whereas those who are not participating will carry on.
will be unaware of the delay and just move straight through.
And the cross-border, that project was a big success and continues to this day, and is fantastic. But what I took from the discussions around that was the different perspectives from the different stakeholders, and where the benefits are not equally shared, or the person paying the bill for the new system isn't able to then have that in their business case, the return makes it extra challenging for the wider adoption.
Yeah, and the reality is, in an interconnected industry like aviation, that's going to be an issue that we're going to have to address. A couple more questions on the safety critical stuff. Do you think we will ever get to the place where we have controller-free controlling, where we have pilot-free piloting or pilot-free flying?
Do I think we'll ever get there? I think eventually, but I think it's a long way off. I think it's a long way away.
A long way away in this industry, or sorry, in your bit of this industry, or of maybe in AI generally, seems to be a very fluid concept. I mean, stuff not only seems to be going, the development seems to be going very quickly, but it seems to be going more quickly. It's speeding up as it goes along. Is the sky the limit? I mean, is there an upper limit to all of this stuff? Do we get to a place where we can get no more development?
Well, I think there's quite a bit to unpack there. The pace of change is accelerating.
That's a much more eloquent way to say it. Thank you. Yes, the pace of change is accelerating.
The ChatGPT was released, I believe, November 2022, and since then we have seen a colossal investment, a real shift, and investment into this new area of technology, and we're seeing almost every week advances. A lot of people are describing this as we're at the base of an exponential curve, and so that as we at each step forward, we're increasing capability ever quicker. So I think it's very hard to answer the kind of question you posed. Will we ever see it? I think we absolutely will, and but not within the next few years, because I think that the safety critical aspect is so important that keeping humans trained, avoiding skill fade, so they have to be fully engaged in a sort of cognitive sense in what's going on. It can't just be a tick box approve recommendation. I think that's very, very important. And so that's actually a much further out. I think there'll be on the sort of non-aviation industries, whether it's cars or buses, as you described, other areas where we see this stuff being deployed much more widely before it gets into aviation, which is actually very different from historically, because aviation was historically pushing forward the adoption of new technologies ahead of everyone else.
Yeah. Mind you, that was a fair time ago now, I think. But so one of the, again, dystopian visions people have of AI generally is that we'll all be unemployed. You're saying, I think, not in our lifetime anyway. But we can't guarantee our grandchildren will ever work as pilots or controllers.
I think there's a different answer to that question depending on where you work. Something that's interesting to think about.
And how old your grandchildren are.
Yes. I think just before this discussion, I looked on the web. There are some various prediction markets or predictions that people are making about the future that seem to change every week now. But within the next 5 years, there seems to be a consensus that there will be androids, building other androids within their factories. What's called the singularity, which is where a sort of artificial general intelligence is something that emerges. A lot of the predictions that are out there on the web talk about 2029 as a year when that becomes something that the singularity happens, where there's an AI that can not only improve itself but is smarter than a human. And so I think that's what makes it so hard to predict which roles and how our lives will change. I think the world of work will change significantly. If we just took the next 2 years, knowledge workers writing documents, working with spreadsheets, so that we talked at the start of the discussion about those use cases. I think that will change radically in the next few years. But I think pilots are good. Those safety critical roles of operating those aircraft will not change in the short term. I think that's much further out.
Yeah, okay, thank you. Only a few minutes left, but ChatGPT is available to anybody at no charge. Do you see that? But there are more sophisticated systems out there, aren't there? That's a question. Which one assumes you have to pay for? Are we going to see AI go the way of the rest of the world, where the rich get richer and the poor get poorer?
I actually think there's a huge opportunity for all of our lives to become significantly better, in that there will be potentially an AI assistant to help each individual person, whether it's on the internet or navigating government websites or performing tasks on the web that currently are pretty mandrolic and painful. So I think that there is a huge change coming, but it's not just with ChatGPT and GPT-4. So currently GPT-4 is the best-in-class model.
Designed or owned by whom?
Designed and owned by OpenAI, the company. And
despite their name, can I just get that, or do I need to pay for it?
You can access ChatGPT for free, but then you'll be interacting with the 3.5 model, which is, if I put simply, not as smart as the GPT-4 model. If you pay $20 a month, then you can access the GPT-4 model. But there are lots of others out there. There's lots of competition. There are also open source models, and I think in particular where the open source community is moving is still behind the proprietary models at the moment, but they're very close. There seems to be a consensus that the open source capabilities are around 6 months behind the proprietary closed models. And the open source models, those can be downloaded and run on a pretty standard laptop or computer today. And the performance of those models is improving all the time. So I think that's something that there's an opportunity where these models are very likely runnable, or will be running on mobile phones by the end of the year, and certainly on every laptop, PC from next year. That
it'll come as a standard piece of software.
Exactly. Yes. Wow. Yes, it will.
And is that a world you look forward to with excitement or with dread?
Excitement. I think I've not in my career. So 2001, I graduated and started working in aviation.
Yes,
So
ladies and
20
gentlemen, he
years.
is as young as he looks, 2001. Gosh.
And I was incredibly excited by the internet, building websites before I graduated, 1998 and shortly after. But I've not been as excited about a technological change since then. And so this, for me, feels like an absolute sea change. This is a step change, and it's
Right.
incredibly exciting, and offers us a huge opportunity to accelerate and improve things across the whole range of use cases and daily lives.
Right. I think that's a really optimistic and positive place to end it. I was going to ask you some of your backstory, but I think you've just given it to us anyway. Graduated in 2001, worked in defence, worked in civil, worked for Cirium. Ladies and gentlemen, I'm sure you agree with me that Alex was incredibly helpful and that was incredibly interesting and incredibly mind-opening. And I'm really grateful to Alex for his time for doing that.